Hello, welcome to my graphics module assessment 1, looking at 5 different graphic materials using the theme otherworldly. And my question is, if cavemen and aliens were to meet, which one would be the other world? So my first material is looking at this as a reference from DeviantArt, looking at this alien, and it's got the blue glowing eyes. So I wanted to recreate that. Maybe it's from the suit, maybe it's the alien's eyes themselves. So here's the texture that I made. It's like a diamond. It's been pixelated with noise. It's not actually a pixelation effect. It's actually an HLSL input um, code that I've created myself. But I take the absolute well position. I get the vector noise from that. I also take the UV coordinates. I pixelate the noise using cos and tan, and then I mostly pixelate. It's not uniform, and then I confine that to the actual UV texture itself instead of the entire picture. So I can change the eye size. A larger value means a smaller eye, and that's been parameterized. I get the gradient of diamond, and then that diamond can pulse using time with a tangent at the sine so that it's out of sync and it creates this stretching effect. I then get the texture, I multiply it by the color, which has also been parameterized. So if I move close to this cube, it turns green. If I move far away, it turns white. This is the master material. So I create a blueprint. This is an instance of that. It's a large eye, and it's green. So imagine it's processing different information. So this is my second material, and for this idea, um, I'm looking at this alien and it's scanning this plant and it's gathering information of this plant, and that information is stored inside of this scanning device, um, using this as my reference. So I really like this. This is my GLSL converted into HLSL example. I don't use the noise, which would be my own custom function. I actually just use the noise node within Unreal, but this is the implementation here. So I'm getting time, I'm slowing it down, I'm getting the absolute well position, I'm combining those to get noise, and that noise is then multiplied by time again to and it creates these circles basically, which get printed onto the material. I then remove the center of the material, um, so that I get the lines, and those lines get printed onto the material using this as the background, and that's the result basically. So just imagine on this blueprint you've got this device, you're scanning information at the front, and then you're collecting that information and it's gathering in the back there. And I really like that. Um, but overall the point is I've gotten the code here and I've converted it into GLSL, um, and it looks very similar, um, which I really like. So that's an example of material 2. What about material 3? So for material 3, that's my example of getting the master material. I'm then instantiating that material, and I'm also using custom functions as well. So you've already seen the the example of that, and that's the noise blur here. Essentially, what's happening is this noise map that's been pre-baked gets mapped. This mapping algorithm generates this noise, and then they get combined together because the map creates these vectors. And you animate it to make it look like you can see these hairs moving. So this is the material here. What I'm doing is I'm mapping. I'm using fractal Brownian motion, um, basically hashing these values here to create FBM, create this variable here, and then I get the map. And this map here is basically the red and the green means directions. So the vector noise gets added into here. So the texture with these samples essentially get stretched at different points, create that fur effect, um, and that's essentially what's happening. So to show that's my custom sort of function that's been implemented, and then this is it on a cape. Maybe a caveman is wearing this in this example here. The cavemen are all wearing fur. This is a different instance where the texture has been changed. So it works with multiple different textures. This is with the different texture, a different color, and actually the wind, the animation has been turned up quite a lot to the point where it doesn't really look like fur anymore. But that's my third material. I hope you like that. And this is my fourth material. So obviously cavemen, they have stone, and I wanted to show stone. Obviously that could be on the end of a weapon, or it can be the cave that they live in. And this is the Shader Toy place that I got it from. So this basically, instead of just getting a stone texture, I'm also applying a normal map to that, and then I'm applying the Phong algorithm as well to give that like almost like a shininess, but also a rigidness to define the normal map as well. And this is some examples of, so that's the master material. This is the instantiated versions of that. So actually different textures can make it look different. The shininess can show more, and it can actually become more metallic. So, you know, maybe the cavemen are more advanced than you think, and they've actually unlocked stone as well, or unlocked bronze, or something like that. So the implementation of this is quite big. I'm fractal Brownian motion, but a different one this time because I'm actually looping through several octaves, generating noise, basically just hashing the UV, and then I pass the information out. So I'm passing the same information out as I get, except for the ST, which gets multiplied by the noise. The information, sorry, gets changed. Um, the output gets changed by the amplitude, which is a float 2. The value gets changed here and gets outputted there, passed into the next octave, which happens again. So I'm also generating my own noise map, which creates a normal map. And what's happening there is it's the same function, creating this noise, and I'm applying different colors to that noise, combining those together to create a normal map, and that's the result there. I then apply the Phong algorithm, which gets that normal map, and it just colors two different sides to give that different color, which then gets multiplied by a texture outputted for the base color, and then the normal map goes in there. And what that does is it creates this really nice stone material here. All right, so that's stone. That's my material 4, and this is my material 5. Using time to animate it here. And this is like an aura. Imagine this black hole texture here, and all the data is getting pushed into this black hole, like the information scanner again. And this is where I got it from. It's actually using Voronoi algorithm to generate this, with the center also being there representing the black hole. And essentially what this is a Voronoi loop. I'm getting this information. I'm sort of creating this center here, which is the C fade, and then this Voronoi loop basically loops different boxes together so they combine together. The Voronoi code here takes in the UV, changes it. That gets looped over, so there's 3 octaves there, and then it gets combined together with the color to create this thing here. So just imagine, Bill, that this machine here is taking in information and sucking in that information and storing it in the black hole. Thank you for listening to my material implementation.